Today we're going to work on lesson 5.1. So in your book, you need to make sure you are on page 237. You can pause the video if you need to get your book ready. That's page 237. Let's look at our I can statements for lesson 5.1. We're talking about patterns for multiplication facts. So we're still working on gaining fluency in our multiplication facts and getting faster at solving them. I can use structure and properties to explain patterns for multiplication facts. I can also look for patterns to solve problems. We can look at relationships when we're using the multiplication table. Max found 6 times 8 equals 48. He noticed that 6 times 4 plus 6 times 4 also equals 48. Use the multiplication table to find two other facts whose sum is 48. Use facts that have a 6 or 8 as a factor. What pattern do you see? So let's look down at our multiplication chart. So I can look at my 6's. Oh, I see 6 times 1 is 6. So I want you to highlight or circle or put a square around the 6 here. And then I see 6 times 7 right here is 42. Then I know that 6 times 1 plus 6 times 7 equals 48. And I can check. I can see 6 times 1 is 6, and 6 times 7 is 42. 42 plus 6 does equal 48. And then I can circle my, so this is 6 times 1 over here, so we could do 1 times 6 over here. And we can do 6 times 7 this way, so then I see 42. And 6 again, and then I'm going to choose a different color to find some more facts. Let's see. Oh, I see 6 times 3 is 18. And I see 6 times 5 is 30. I know 30 plus 18 is 48. So then I can circle it the other way too, starting with 6 times 3 over here, 18. And 6 times 5 over here, 30. So just some different patterns that we see. Let's look at the bottom. How can a multiplication table help you find products that equal 48 when added together? So the table helps me see that as one factor increases, the other factor decreases. So for example, as I see 6 times 1 is 6, then I have 6 times 7 down here. But then if I increase one factor, 6 times 3 instead, then my next factor would be 6 times 5, so that is lower. Let's look at the next page. We're going to look at another example. Yolanda noticed that 4 times 6 is double 2 times 6. How can you explain this? So I see 6 times 2 is 12, 6 times 4 is 24, and I know 12 plus 12 is 24. 4 is double of 2. So 4 times 6 is double of 2 times 6. We can think of 4 groups of 6 versus 2 groups of 6. We can think of the distributive property of multiplication to explain. So we know 2 times 6 is 12. 2 times 6 is 12, so 12 plus 12 is 24. Look at the highlighted rows. The product of any number multiplied by 4 will be double the product of that number multiplied by 2. So 2 times 1 is 2. 4 times 1 is 4. 2 times 2 is 4. 4 times 2 is 8, so we see that they are doubled. Look at the highlighted rows of numbers multiplied by 2 or 4. What pattern do you see across the rows? So we can see that when multiplied by 2, the product increases by 2. And as the other factor increases, when multiplying by 4, the product increases by 4 as the other factor increases. So they're just saying that as we multiply, we get more groups. 2 times 1 is 1 group of 2. 2 times 2 is 2 groups of 2. So that's 4. So it would double, and it would go up by 2 each time. Then if we look at our 4 rows, I see 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. We don't need to write anything for that one. We'll practice a few more together. We're going to skip numbers 1 and 2 on this page. Let's look at number 3. What pattern do you see in the columns and rows that have 0 as a factor? So we know anything times 0 is always 0. So we can say any number, this is the sign we can use for number, times 0 is 0. So those are all zeros because when we have one factor or one number that we're multiplying by 0, it's always 0. Explain why this pattern is true. We kind of already did it up there. Number 5, look at the shaded products. What pattern do you see? So I see 0, 8, 14, 18, 20, 20, 18, 14, 8, and 0. So I notice that each product, I see a 0, and then I see a 0, an 8, and an 8, a 14, a 14. All the products appear twice. Now we're going to write the equations for these. So if I look down here, I see 9 times 0 equals 0. Then if I look at my other 0, this would be 0 times 9 equals 0. And we're just going to do a couple of these. I see my 8, that would be 8 times 1 equals 8. And then my other 8, I'd say 1 times 8 equals 8. So we know that these will give us the same number because when we flip the numbers in multiplication, the order doesn't matter. We'll get the same product. So we can say the order doesn't change the product or the answer. Now we want to shade a line in the multiplication table to show how this pattern is true for other products. So we could find our 4 rows. So no, 0 times 4 is 4. 4 times 0 is 0. So I could shade this one in. I'm not going to shade all the way because I want you to still be able to see the numbers. And then I see 3 times 1 is 3. 3 times 1 over here is 3. And then 2 times 2 is 4 because it would be the same, 2 times 2. So that's one example of how the order doesn't matter because 4 times 0 is the same as 0 times 4. Let's look at our next page. Number 9, how many arms do 9 starfish have? If each starfish has 6 arms or each starfish has 7 arms. So we'd have 9 for A. And we have 6 arms, so we do 9 times 6, or I know 54, so there'd be 54 arms. 7 arms, we do 9 times 7 instead to get 63 arms, because if there's more arms per starfish, there'll be more arms total. We're going to skip number 10. Let's look at number 11. The distance from Tom's house to his brother's house is 200 miles. Tom drove 38 miles in the morning and 57 miles in the afternoon. Estimate how much farther Tom has to drive to reach his brother's house. So when we can do this, we know Tom drove 38 miles and then he drove 57 miles. So we can estimate or round these numbers to estimate our final answer. So 38, I see the ones place as an 8, so we round up, so it would be 40 miles. 57, we also round up because the ones place is a 7, so we do plus 60. And these are easier numbers to work with, which makes it an easier way to estimate. So 40 plus 60 is 100. And we know his house is 200 miles away, so we know he has 100 more miles to drive. And that's not exact because we didn't use the exact numbers, but that's about how many miles he had. If we wanted to find the exact, we would add up the 57 and 38. We're just trying to find an estimate. Cross off number 12. Let's look at number 13. Shade the ones rows and the ones columns on the multiplication table. So we would want to shade. So we want to shade the ones columns here. And the one row here. We want to think about what pattern we see. We know that anything times 1 is just itself. So the products are equal to the factor or the number we're multiplying, the number that is multiplied by 1. And I'll just say times 1 because I'm running out of room. So the product are equal to the factor that is times, that we're multiplying by 1. So 2 times 1 is 2, 3 times 1 is 3, and so on. And we know when I multiply by 1, when I times by 1, the product is that number, the identity rule that we've talked about before. For your homework today, I want you to turn to page 241. Remember, the top just shows an example. I want you to circle number 1, 2, and 3. So we're finding a column which has products that are some of the yellow shaded numbers in each row. And we want to shade this column. So I'll give you a hint for 1. We can shade it together. That will be this column because I see 2 plus 4 is 6, 4 plus 8 is 12, and so forth. We want to see what pattern, explain why it's true. Find a similar pattern using different products and shade the columns on the multiplication table, and explain how you chose which columns to shade. So you're finding another pattern that you see. So you're doing 4 and 5. Then on the back, we're going to do number 8. And 10. And 11. And then you can send me a picture on Seesaw of your work.